Today we'll be speaking about database as a service, leveraging the VMware Cloud platform. So we will be initially talking about the VMware platform itself and what it offers for service providers and internal IT to offer database as a service. Then once I've introduced that topic, Darshan, who works for ScaleGrid, DBaaS as a service provider, would talk about how database as a service can be deployed on VMware and all its benefits, and then I would conclude in the end. So I am Mohan Potheri. I'm a staff solutions architect at VMware, focusing on technical marketing, and I work for the Cloud Services BU, and I focus on the database and other services, including AI, ML for VMware Cloud. Darshan, why don't you introduce yourself?
Thank you, Mohan. Thank you for the quick summary. My name is Darshan. I'm the founder of ScaleGrid. And at ScaleGrid, essentially what we do is we build database as a service solutions, and we focus on public and private clouds. And in this presentation, I'm going to work with Mohan and share the details of our database as a service platform on VMware infrastructure.
Good. Okay, so let's move on. So if you look at how things are accelerating today, application deployments are really accelerating. So in the next 5 years, there will be more applications deployed than in the past 40 years or 4 decades. So it's crazy how applications are proliferating in the organization. That means we need a big transformation for the digital foundation. So you need a flexible and hybrid approach so that all the workloads that are coming in the next few years, we are able to host in a scalable, available, and secure manner. And that's the big challenge that we have. So this is kind of how we see today and how things are transforming for tomorrow. So you see all these different areas where more and more applications are going to be deployed. And you see a massive need for a scalable platform that can do all of this. And one of the core components of data storage is our databases. So these applications will be storing data, and they would be storing them on databases. So kind of this topic leads into how databases and how databases need to be deployed as part of all these applications to in a seamless, streamlined manner, so that these applications can be deployed easily and available in a timely manner. And if you look at 2019, the IT spend for the line of business exceeded for the first time ever the operations spend. So that means that applications are slowly taking over, and more and more a part of the budget. So between 2019 and 2024, it is expected that enterprises will build more than 500 million apps. So, and a lot of it is cloud native, and there's still a lot of traditional apps. So there's going to be a mix of both. And over the next 5 years, you would see that there's a need for the legacy apps to coexist with the modern apps, and they kind of interact with each other as well. And if you look at what VMware has done over the past few years, it has been ramping up to serve its customers in this area. For example, if you look at all the acquisitions that VMware has done, and at the bottom, you will see a lot of these are application oriented, monitoring, application packaging, Kubernetes, Bitfusion for sharing accelerators, all these different aspects that we procured and brought into our platform are meant to service this new need that we're going to have for all these applications being deployed. So if you look at IT infrastructure today, to some extent, even though it might be virtualized, there are a lot of different silos that are there. So in the sense there's racks of servers, there's racks of storage, there's networking, security is also isolated to some extent. And so you have all these different components that need to interact sometimes in a top-down manner rather than in a horizontal way. So this is kind of what the status of the IT infrastructure today is. And so you can see all these different silos that are part of these traditional apps, right? And so as we move to the next phase of application deployment, we want to make sure that with all the growth that we are predicting, we need to be able to make this more seamless and easy to leverage for our customers. And this is kind of, as you can see, is very complex and resource intensive as it stands now. The agility is limited. And also a lot of the internal customers of enterprises go and kind of buy their own shadow IT. They go get their cloud resources and they create their own silos. So we need to kind of bring this all together. So that is our goal. If you look at what the main goal of the VMware platform is that we create the solutions so that we make the complexity invisible to our customers. Rather than focus on all these complexities, you can focus on transforming your business. And so that's kind of the core value prop that VMware brings as a platform. So now let's look at the history of VMware to some extent and how we have evolved over these years, right? We have moved from hypervisor, where we first started in the late 1990s, early 2000s, where we brought virtualization to the fray. We consolidated a lot of infrastructure that was physical. We showed customers, enterprise customers, that only 20% of their servers were really being utilized, and helped them consolidate that infrastructure, save a lot of money in the bargain, and also bring in capabilities like HA, DRS, and other capabilities. So that's in the initial tactical phase of the platform, right? And then we've slowly evolved. vCenter was brought in as a management platform, providing all the capabilities to manage and operate on the environment. And over time, we evolved from, if you look at all the down area where we're moving from tactical to strategic, we introduced the concept of the software-defined data center. So where all components such as compute, storage, and networking are defined, are software-defined, and everything can run on top of the hypervisor. And by doing this, we've made it more cloud-like, right? So when you want to be able to deploy on any cloud, anywhere, you want all these components of compute, storage, and networking, which are the core components of infrastructure, be definable via software. And that's what we see in the V3 of this evolution. And then now we are moving to this hybrid cloud phase where we are actually truly transformational. We have ported our infrastructure to a lot of the major cloud providers, such as AWS, Azure, Oracle Cloud, Google Cloud, and all the other providers such as IBM, Alibaba Cloud, and all that. And so we have the same look and feel. You can literally vMotion VMs from one cloud to another. And so we have built this, we built on what we've done over the past 20 years and kind of now giving the capability to our customers to do the hybrid cloud. So that's kind of how we evolved, and you can see that the hybrid cloud can truly be transformational because your applications can run anywhere in any cloud, and with the same look and feel and the mobility and agility that you would require. So let's look at some of the architecture components. So if you look at traditionally, you have data centers. Let's say a typical enterprise has a couple of data centers, and then on top of that, you have servers, storage, and then the layer on top of it, software-defined data center. So we have vSphere for compute, vSAN, vVols, and VMFS for storage, and NSX for networking. And then let's look at what we provide through vSphere, right? vSphere has evolved over the past 20 years. It is, it is the most advanced hypervisor out there. We've developed vMotion capabilities, high availability, and all that, and we've evolved that over the past 20 years to make it one of the most user-friendly platform to use, as well as the easiest platform to use, right? And it helps you streamline your development, create an agile operations, and also helps the organizations accelerate their innovation. And then if you look at it now, the latest evolution of it, we now support Kubernetes. So we are bringing together the world of vSphere with the world of the Kubernetes. And as I said earlier, the worlds of modern apps and legacy apps are going to be coexisting for a while, and then this platform brings it all together. Now we look at storage. Here we saw vSAN primarily, but vSAN is a hyper-converged offering, and we have vVols for traditional arrays, and we have VMFS as well. So storage can be truly software-defined as well, and it provides it can run on top of standard x86, and it provides a lot of capabilities through what we call a storage policies. And a hyperconverged storage provides ability to for service providers to have all the components that they need within a rack. And what we provide through VMware vSAN and storage policies with vVols and other aspects is that we provide simplified lifecycle management. Now with vSAN, we also provide NFS, which is like integrated file services. And we also provide drivers for cloud native storage. So the storage that we provide with our software-defined storage can help with both legacy apps and modern apps. Last but not the least is networking, and networking needs to be is the glue, as you can see, right? The networking provides not only connectivity within a data center, it also provides connectivity across data centers. So when we talk about hybrid cloud infrastructure, you are actually having your workloads running across data centers. So NSX is our glue to this modern cloud era. And it provides you the ability to connect VMs, containers, physical servers, private and public clouds together. And so that's kind of the core value proposition that our software-defined networking offers. And if you look at some of the areas that we provide capabilities are, we can define our networking as code. We provide simplified operations. We can scale with the cloud. It has inbuilt security, so there's the intrinsic security built in. Microsegmentation is a revolutionary concept that we introduced, and it provides east-west security, where you can provide security at the level of a VM without having to have a hierarchy, as in the traditional secure environments. And then we also provide analytics and visibility to the environment, into the environment. So, so as we can see, this leads to what we have built as the final evolution for the hybrid cloud is the VMware Cloud Foundation. The VMware Cloud Foundation is the next generation of the software-defined data center. where we are bringing together all the components and we're able to manage a lot of different workloads together, in addition to being able to manage multiple data centers and multiple environments. So that's the unique capabilities of the VMware Cloud Foundation. And this is the control plane for the SDDC, and it provides you lifecycle management, policy-based provisioning, configuration, and deployment. So before I conclude on the introduction to our platform, I just wanted to, this kind of provides you an overview of the visibility into multiple data centers across multiple geographies, and you can federate across a lot of different areas and manage them all centrally using what we call as the SDDC manager, which is the management component of the VMware Cloud Foundation. So now I'm going to stop sharing and pass it on to my colleague here, Darshan, to talk about database as a service layered on top of the platform we just described. Take it over, just Darshan.
Thank you, Mohan, for the great overview, and thank you for explaining the VMware infrastructure in detail. So let me build on top of that. And I'm going to talk a little bit about how our database as a service, layers on top of the VMware infrastructure. And before we get into the details, I want to sort of, take you through the problem statement a little bit. If you look at the enterprise landscape today, right? Enterprise DBAs, they are being asked to do more and more with less and less. They are still handling all the traditional tasks of query monitoring, some backups, some upgrades. And along with this burden, in the last 10 years, the database landscape has changed tremendously. Two of the big changes that have happened. The first one is the arrival of the cloud, and the second one is the arrival of different types of databases. And traditionally, people had their own racks deployed on their own servers, then they were deploying on virtual machines. But nowadays, DBAs, they have to deal with various different clouds, AWS, Azure, GCP, and all of these clouds bring their own nuances in terms of, performance, security, compliance. So this greatly increases the burden on the DBA. The second major change the DBAs have to deal with is the arrival of the new and different types of databases. If you looked at the database landscape 20 or 30 years ago, essentially when you said database, you typically meant Oracle or SQL Server or maybe some DB2. And today the landscape is very different. And empirically, as we talk to our customers today, we see that most of them have at least 3 different kinds of databases deployed. There's still the traditional OLTP layer with the Oracle, the SQL Server, MySQL, Postgres, and in front of these layers, typically there's a caching layer which is now increasingly Redis. And beside or behind these databases, we also see other sort of workload-specific databases. For example, if you're doing document processing, we usually see MongoDB. If you're doing a lot of IoT or write-intensive applications, we see Cassandra. If you're doing text analysis, so we see Elasticsearch. And there are a lot of organizations using graph databases as well. So essentially, we call this we call this a polyglot deployment, where a single organization is deploying multiple different kinds of databases. And we see this as the future going forward. And all these databases, they are slightly unique. They all have their own nuances in how to deploy them, how to scale them, how to monitor them. So for a single DBA team to essentially build and manage these databases is becoming a challenge, which is why more and more organizations are looking for a platform to help them manage these databases. And there are many other drivers driving this DBaaS as well. The first one we talked about, people want to leverage the public cloud, they want to leverage private cloud. And increasingly in the last few years, we have seen 2 other interesting trends where people are doing hybrid clouds, where from a single console, they want to deploy some databases on-premise on VMware, and they want to deploy some databases in the cloud as well. And another new trend we're seeing with databases is multi-cloud, where customers want to be cloud agnostic, in that if a single cloud goes down, they don't want their applications to go down. So we are seeing an increasing trend where customers are distributing the databases across on-premise, AWS, Azure, and so on. This way, they are not tied to a single infrastructure. And we talked about the complexity with the different databases and data warehouses. Options are also available. And more DBAs are looking to do dynamic transforms of the data. Essentially, they want to real-time replicate data from, say, Postgres to MongoDB, MongoDB to Elastic, and back and forth, and so on. So all these requirements are driving complexity. And the way organizations are handling this complexity is by building and using database as a service platforms. And this is the platform we provide in ScaleGrid. So we provide a database as a service platform. And essentially, this platform supports various databases, MongoDB, Redis, MySQL, Postgres, and SQL Server. We're adding support for Oracle as well. And we support both public as well as private clouds. And in public cloud, we support AWS, Azure, GCP, DigitalOcean, Linode. And in the private cloud, we support VMware and OpenStack. And the premise of our system is that essentially, our system will automate all the routine tasks, and the user can essentially, and his team can essentially focus on just the development side of things. So for example, the provisioning, the backup, the restore, the scaling, the firewall management, the log management, encryption and transit, encryption and rest, OS management, all that is handled by the ScaleGrid platform. Think of the ScaleGrid platform essentially as a layer sitting on top of your VMware infrastructure. It is leveraging the underlying VMware infrastructure and giving you a DBaaS experience on top of VMware. And we essentially give you a single pane of glass to manage all your databases from a single console. And this enables you to sort of stabilize and simplify your IT infrastructure. This way you can build your IT infrastructure across all these databases on a single console, as opposed to going and integrating with different solutions for different vendors. And a quick summary of our sort of high-level platform advantage. The first thing I want to talk about is, ScaleGrid provides like a polyglot platform. So we support multiple different kinds of databases: MySQL, Postgres, MongoDB, Redis, SQL Server, Oracle, Elasticsearch. This way, you have a single platform to manage all databases in one pane of glass. We're also a polycloud platform. And unlike other sort of database as a service solutions, we are a little different in that, our solution is not a black box. And when you deploy ScaleGrid on top of VMware, and you have full access to the underlying VMs, and you also have admin access to the database. And essentially what this does is it enables a long tail of scenarios. For example, a lot of our customers, they are already monitoring all their application servers using Datadog, and they would like to install the Datadog agent on the database server as well. So because the customer has access to the underlying machine, they are able to install the Datadog agent, and they are able to basically get our database servers to integrate with the underlying platform. And ScaleGrid has been around for 8 years now, and we power thousands of deployments, and VMware is also one of our customers, and they use them for various of their database platforms. Okay, and one thing I'm going to do now is I'm going to quickly switch to a demo. This way I can actually walk you through how ScaleGrid works on an existing VMware infrastructure. Now, the demo we have up today is our essentially our Postgres solution, but it works very similarly across all our different solutions: Postgres, MySQL, Redis, MongoDB, and so on. Okay, so at a high level, this is our ScaleGrid console, and you can essentially use this console to manage all the different aspects of your database servers. So at the first step, what I'm going to do is I'm going to walk you through how ScaleGrid integrates with the underlying VMware infrastructure. ScaleGrid has a concept of cloud profiles. So essentially, cloud profiles are how you can configure your IaaS infrastructure in ScaleGrid. And in this example, we're going to talk about VMware. And essentially think of a cloud profile as a collection of your underlying cloud settings. And in case of VMware, we will integrate directly with vCenter using the vCenter APIs. So essentially, you can pick your compute nodes, whether it's a cluster, whether it's a resource pool or a host. You can pick your data stores, you can pick your networks, and essentially you will create a cloud profile. And people typically create different cloud profiles for dev, for test, for staging, for production, and so on. Okay, so essentially in this screen, you can create a new VMware cloud profile. Let's call it the demo cloud profile. And let's pick Postgres. And in terms of, so let me just get the details here. So in terms of integration, you would point us to an existing vCenter infrastructure. And so we will authenticate to this vCenter infrastructure using a vCenter username password. And underneath, ScaleGrid is built on the VMware API. So we use the Java API. So we integrate tightly with all of the VMware infrastructure. And essentially, our system will go in, will query all the VMware infrastructure, and will present you a view where you can integrate at the compute level, network level, storage level, and so on. At the compute level, you can integrate, you can choose to create a cloud profile. You can map it to either an ESX level, or you can do clusters, or you can do resource pools as well. So for example, in this case, I can map this to this particular resource pool. Okay, and you can choose the data store on which the VMs need to be deployed. You can also choose the network on which the VM should be connected. You can also specify a location where you want to store all your backups. Okay, and then at this point, you can create your VMware cloud profile. And once the cloud profile is created, it will show up in this list and it's available for deployment. So let's go through a sample deployment at this point. So for example, you can go in and you can say new Postgres deployment. Let's go bring your own cloud. Let's call the name of the deployment called demo. And here, as part of the target of the deployment, you can create your, you can basically select a cloud profile that you created. So this way, it makes it agnostic of the underlying infrastructure. So you can, as and when you add new infrastructure, you can create new cloud profiles, and essentially, you can have your database layer agnostic of the underlying infrastructure. So I'm going to select the cloud profile we just created. In terms of sizes, in the spirit of the cloud, we provide 7 or 8 sizes. Each size you can map to like the number of cores, the type of the disk, and size of the disk, and all of this you can sort of configure on a per account basis. And in terms of versions, we support about 3 or 4 major versions, and you can pick the version that you want. You can also enable high availability for your database. So ScaleGrid internally handles all the necessary jobs, necessary tasks for high availability. For example, in Postgres, we will handle Postgres replication. From the UI, you can choose a 2 or a 3 node deployment. From the CLI or the API, you can have more power and you can do more custom configurations. You can choose synchronous or asynchronous replication. And ScaleGrid will essentially set up the replication, and it will handle all the high availability. For example, if your master goes down, automatically from the remaining nodes, a new master will be elected. And if you're on the VMware infrastructure, we also ask for a static IP. So essentially, whenever there is a failover of the master, the static IP will be automatically mapped to the new nodes. If you're on cloud infrastructure, we can do the same thing with a DNS name, where we provide a virtual DNS name, and we will automatically remap it to the new master. And you also have fine-grained control over where each replica is located. For example, you might choose to put 2 of your replicas in one data center and have the third one in a different data center. So this, this screen gives you fine-grained control over where each of your replicas are located. All right. Okay, and then we'll also ask you when you're deploying high availability configuration. So we'll also ask you for your entry point. So essentially on-premise infrastructure, you can provide a static IP, and static IP will essentially be moved with the master, whenever there is a failover. You can also enable encryption in transit, SSL, and we also support encryption at rest. So essentially, we support encryption using OS level encryption. So whenever you're enable encryption at rest, your snapshot-based backups also will be encrypted at rest. With Postgres, Postgres is a process-based database, so scaling connections is always a problem. So essentially, we have enabled the built-in sort of connection pooler. PG Bouncer is the most popular connection pooler for Postgres. So you don't have to do anything extra to deploy it. It is built into the system. So you can just enable it at creation time, or you can enable it once it is created. So the system just gives you a summary of all the options you selected. And once you click create, we automatically trigger a job from our system. And think of this job as an automated sort of history, and it'll give you all the different actions that are running in the system. So for example, you can see all the ones that are succeeded. If they are failed, it'll tell you the reason why it failed. And for each job, it will give you a list of steps and the time taken for each step. Once the job is done, you will see the cluster up and running on the main screen. You can click into it. You can go into the details page, and you can see all the different management options we offer for the cluster. And the first thing I want to talk about is our monitoring console. So all databases come with built-in monitoring. Nothing extra is needed. It's available as part of the ScaleGrid infrastructure. And for every database, we'll show the major operations on the database in terms of inserts, updates, deletes. And all these graphs that you see here, they're all click to zoom. So if you want, you can click and zoom into a particular time frame. We capture all the OS related metrics from the CPU to load, swap, disk usage, network usage. And we also capture all the database level metrics. So for example, the number of connections, checkpoints, conflicts, deadlocks, cache hit ratio. So essentially everything that you need to monitor your Postgres server, you will find on the screen. And the data is captured from 1 hour up to the last year. And then as you go further back, essentially, the data gets averaged out. We also have the ability to compare different servers. So for example, let's say you have a couple of servers and you want to see how they are going to stack up against each other. So essentially, you can come into this compare view and you can stack up these servers side by side, and you can look at this metrics. And this gives you an easy way to sort of compare different servers and make sure you can see any anomaly between these servers. Now, all the metrics that I presented in the previous screen, you can create alerts on all these metrics. So we have a custom rules engine. So we have cluster level rules, account level rules, and global rules. So you can come in, you can create a new rule, alert rule. So for example, let's say you want to create an alert rule when the number of, say, inserts per second is greater than 1,000. You can come in, you can create a new rule, and you can choose the different types of notifications for your system. Email is default. You can choose SMS notification, PagerDuty notification, Slack, or Ops Genie. Right now they look disabled because we haven't put in the keys. So as soon as you put in a Slack key or an Ops Genie key, that particular option will get enabled. You can create the rule. Once the rule is created and the condition is triggered, essentially the alert will show up in the active alerts. And once the condition goes away, the alert gets dismissed. The next thing I want to talk about is our query analyzer. So, once a server is up and running, pretty soon the next problem you will hit is, somebody will complain that the server is slow. So essentially, what we did is, we automated this process of analyzing what is going on the server. So you can pick your server and you can pick your time range. This can be the last hour, last 24 hours, or you can pick a custom range and you can say profile. And essentially what our system does is it goes in and builds a heat map of all the queries running in the system in that time. And x-axis is time, and y-axis is duration. So the higher up it is, the more slower the query it is. And we also go in and we sort of normalize all these queries. We deparameterize them. So all queries with the same shape, they'll have the same color. So this makes it sort of very easy for you to essentially in one glance figure out what queries are hitting your system, how they are clustered, how much time they're taking, and so on. And again, all these graphs are also click to zoom, so you can zoom into a particular area if you want. Okay, and in order to make it further easier for you customers, so essentially what we do is we will break down the read load and the write load so that we can easily identify which queries are causing read load and which queries are causing write load as well. And typically if your queries are causing read load, it's usually an index issue, so you can quickly pick up the query and I can go make sure it is indexed accurately. And all the information that we presented earlier is also available in tabular format, so you can see which query was causing the issue, what was the frequency, and what was the duration, average duration, what was the number of rows returned, rows scanned, and so on. And for the more complicated queries, we can also do visualize the query plan. So essentially, when your developer builds the query, he would have had a query plan in mind. But essentially, when it hits production, it may or may not, run with that query plan. So essentially, you as a DBA, you can take this query plan, you can go back to your developers and make sure that this is the plan they had in mind. Okay, and in terms of backup, our system automatically handles all the different backup options. So you have on-demand backups, or you can schedule backups, and typically you will do on-demand backup for an application event. Let's say you are releasing a new version of your application, you want to back up your database before you do that. And schedule backups, essentially you can set up a schedule, how frequently you back up, how many backups are retained, and so on. Similarly, restore is a one-click operation. So essentially, all you have to do is you have to select the backup and you have to say restore, and our system will do all the work necessary to basically, swap out the disks, make sure all the replication is set up and the system comes back to run. And one common request we get, is typically, most customers don't want to restore data. But sometimes what happens is they have deleted a row by mistake, or they have deleted a document by mistake. They just want to go back and get it. So we have built this selective restore flow called pcat backup. And essentially what pcat backup does is you can select a particular backup that you want, and essentially our system will create a new standalone instance with that backup. And this is independent of your production instance. So essentially once it's up and running, you can connect to it, you can get the data that you want, and you can throw it away. Similarly, we have the clone functionality as well. And a clone is typically used for testing. Let's say you have a production setup and you're releasing a new version of your application and you want to test the application with production data. You can click clone, and this will create an exact copy of your production system, same size, same data, everything. And you can test your application with this clone, and then you can, once it's done, you can throw it away. Scale is also an in-place scale operation. So essentially, what we do in ScaleGrid is we do a rolling scale operation. So let's say you have a Postgres deployment with a master and multiple standbys. We will start with a standby. We will take it down. We will scale up the compute if necessary, disk size, disk IOPS, bring it back up, wait for it to sync, move on to the next node. So this way we will do a rolling scale operation. It is one node at a time. And essentially, you can do an online scale with pretty much no downtime. And the only impact your application will see is there's a failover of master from one node to another. And the failover time is typically about 30 to 40 seconds. We also generate monthly reports for our users. Essentially, we'll send out a report every month that essentially gives you what was your load over the past month, and what was tables added, tables removed. And we also show all the activity stats in that, what were the number of tables, what were their sizes, what were the number of indexes. With Postgres, dead rows is always a problem. So we'll give you an estimate of which tables have the most bloat, which indexes have the most bloat. And we also capture a lot of the activity data, which tables are the most read, write, and so on. Okay. And we also give you different options to import your data. If you have an existing Postgres server, we can import the data. And we offer two options. You can do a one-time import, or you can do a live sync. And essentially, if it's a live sync, it's a two-step process. First we will do a dump and import of data from the existing server, and then our system will automatically tail the change logs. So this could be wall in Postgres, or bin log in MySQL, or uplog in MongoDB. And essentially, our system maintains a real-time clone of your existing cluster. And whenever you're ready, you can essentially stop writes to the original server, and you can switch your connection strings to the ScaleGrid server. And we also provide a bunch of other functionality. You can see all the logs, you can see all the current operations on the server, you can see all the connections by client IP, and we also handle all the configuration management. So essentially, our system presents you all the Postgres parameters, and our system is aware of which parameters require restart, which parameters don't require restart. So essentially, you can come in, you can save the changes here. And if the parameter requires a restart, ScaleGrid is aware of it. It can do a rolling restart, one node at a time, with minimal downtime. That was a high-level view of Postgres functionality, and we have similar functionality for MySQL, Redis, MongoDB, SQL Server, Elastic, and so on. And essentially, to summarize, think of ScaleGrid as a DBaaS layer on top of your existing VMware infrastructure. This could be either in the public cloud, or it could be in the private cloud. And we sit as a layer on top of the VMware infrastructure to essentially give you like a DBaaS experience on top of VMware. With that, I would like to hand over to Mohan.
Thanks, Darshan. I will share my screen again. Okay.
And while we're waiting for Mohan to share his screen, just a friendly reminder that if you do have questions or comments, we're going to take those in the Q&A.
So to finalize, so we initially talked about VMware's platform, and VMware is uniquely positioned, as you can see, as a true cloud platform for things like DB as a service. So it's a great platform in the sense that we have built it over the past 20 years. We have all the components necessary, building blocks necessary, and ScaleGrid clearly demonstrated how they can leverage our platform and build on top of it and provide you a world-class DB as a service for multiple databases. So cloud providers like VCPP partners and others can leverage solutions like ScaleGrid on top of their infrastructure and offer it as potential services for their customers. And it also can be deployed across all the different clouds that we support, and is truly can be a multi-cloud / hybrid cloud solution. So, with this, you can see that VMware is really positioned for the future, and and is the industry leader, as you can see in the slide. Server virtualization, all different areas that matter. We are like the top provider, and so that's. And with that, I would like to conclude this presentation.
Great, thank you very much. And we do have a question. Thanks for the comments as well. I'm glad you think the information is useful. There's a question though about, is it possible to use this solution with Cloud Director, not only with vCenter?
So so ScaleGrid has initially worked with vCenter and deployed it. Certainly, with the interest from cloud providers, we can certainly do vCloud Director as well. So, but that is in the roadmap, but not yet worked on yet.
Okay, great. And I know we're wrapping up and we still have a few minutes. I want to go any last minute comments or thoughts that you want to leave our partners with as we do wrap up.
Yeah, just want to reiterate that, we provide, VMware provides the building blocks, right? And we have built this over a couple of decades now. So it's all coming to fruition. And as you look to the next 5 years, when there's going to be rapid growth in applications, our platform is truly ready for it. And so I recommend all our partners to leverage the VMware platform to build services like the DBaaS service that we showed today.